lesson 2. Today we're going to be asking the question, what is the scientific method? The scientific method is an organized way to help scientists begin to solve problems and questions. Like, what is this giant orb in the sky? Why is it flying across at night? How come the stars are so small? These are all things that science had to figure out at one point or another, and some scientists are still trying to figure out what different colors those little sparkles in the sky are. Some are giant nebulas, others are wee little tiny stars that we're just getting the light from that have burnt out millions and millions of years ago. So the scientific method has 5 steps. And the first step is the question. What do you want to learn? What is vexing you? What is causing you to make a question? I'm interested in this. What is that? The next is research. You want to find out as much as you can. There's a whole lot of people on this planet, and we've had a whole lot of people that have lived a long time. Maybe they've already found the answer. Maybe the question you're asking has already been solved or has been solved by multiple people who never had a chance to communicate, and you can look at their different information and see if it resolves your question. If it doesn't, then maybe you need to go on to the next step. The next step is make a hypothesis. What do you think the answer is to your question? Obviously, they didn't have an answer, but maybe they could help you to get to the answer you want. So now you have to figure out, how can I make my question make sense, and what do I think the answer is going to be? So that's going to take a little bit of thought. Now we get to the fun part, the experiment. You're going to design a test to see if your hypothesis is correct. So now you're trying to figure out, I know what answer I think is going to happen. I know the question I have. How do I get the middle bits, the part to figure out how to answer that question and make sure that my answer is correct? So that leads us to the conclusion and peer review. So we've done our experiments, we've got our information, we've looked at it. Now we're going to look at it more and see if it actually solves our question or opens up more questions. So now we have a question that we started with, we made our hypothesis, we've done our experiments, now we have more questions, which happens a lot. And once we get all that information, all that data together, we want to hand it off to a friend. We want to let our friend look at it. We want to let them run experiments and them test it out, because maybe there was something we were doing that was just a little bit different and they're doing something a little bit different, and maybe they'll actually get to the right answer, or maybe you'll have had the right answer, they'll test it, and they'll get the same answer, and you know you've got the right answer. So that's awesome. So we're going to do a little scientific method ourselves. So we're going to start with this. Does the temperature affect how salt dissolves in water? So we're going to think about that. I already did a little bit of research before we started today, and there's a few things I found out. I found out that salt is a crystal. I don't know how that's going to affect us, but it's good to have that information just in case we need it later. We know that water atoms move slower when they're colder. So the colder they get, they move really slow. In fact, they get to move in so slow when they're cold that they'll form ice. They'll stop moving and they'll just lock in place, and they'll change states from a liquid to a solid, because that goes from water to ice. That's what happens when it gets really cold. Now I'm going to form a hypothesis with some of that information. Oh, but wait, I forgot one of the coolest parts I got in my research. Salt actually does dissolve in water. The very thing we're trying to figure out, we just want to make sure that it actually dissolves. What if we put sand in? Does sand dissolve in water? Ooh, that's another experiment we can look into. But for right now, we're working on the salt. So I think salt will dissolve the same way in any temperature of water. Because if you think about it, salt in water is salt water. The earth is covered in ocean. And most of the ocean, all of the ocean is salt water. So is there salt water in the North and South Pole? Yeah, it's cold. They got salt water. Is there salt water around the equator, like around Hawaii or North Africa? Yep, all salt water, all the way down, all the way up. Salt water. So I think it'll dissolve the same amount in every type of water, all right? Now, we're going to get to our experiment, but before we start our experiment, we want to start thinking, what are we going to need for our experiment? We're not just going to walk to a table, throw a whole bunch of salt and water and see what happens. No, we want to make sure we know what we're doing and we have the supplies we need. So for this experiment, we're going to need 3 glasses, water, But the water is going to be in 3 different types. We're going to have hot water, cold water, and room temperature water. So room temperature water is just water that you put into a cup and you let sit in the room. The temperature of the room, temperature of the water, they'll kind of even out, and then you'll have room temp water. Kind of easy. You'll need salt. How are you going to make salt water without salt? And a measuring spoon. So the measuring spoon is important. That way you can always measure the same amount of salt for each one. That way you're not putting more in one and less in another, so it makes it look like it's dissolving a little differently. And then once we do our experimentation, we're going to draw our conclusion. But part of the experiment is taking data. Now, data, I've drawn a nice little array here for you. And I put temperature up here, so I know what these are describing. And I've got cold, room, and hot, the 3 kinds of water we're using. And I know that if I run an experiment once, it might give me the right answers, but I might want to do it a few times just to see if it is the right answer. So I've got experiment 1, experiment 2, and experiment 3. So I'm going to run this experiment 3 times. Now, I'm going to pour my water in, I'm going to watch it, and I'm going to see what happens. If it dissolves, it gets a yes. If it doesn't dissolve, it gets a no. That's pretty simple. In the future, if I'm wondering, because I see something's happening, I might try to time it and see how fast it dissolves. I could use sugar to see if sugar dissolves at the same speed or under the same conditions. And there's different types of sugar. There's demerara, there's white sugar, there's unrefined cane, huge word, sugar. And I can do all these experiments as well. So let's get to the experiment. Thanks, Mr. Bones. All right, so we've set up our experiment and I've got my 3 glasses. I have my 3 waters. I have cold water here, which I've put ice cubes in to make sure it's nice and really cold. I have my room temperature water, which I just put tap water in and then left it in the room for about an hour, and now it's about the same temperature. It'll feel cold to the touch, but it's about room temp. And Mr. Bones got the kettle and gave me some boiling water. So it's not just hot water out of tap, it's boiling. If you want to use this or really hot water, make sure your parents are around to help you out so you don't burn yourself, because you have to be very careful with this. Now, salt, the other part of the experiment, and a measuring spoon. I want to make sure I'm using the same amount of salt in each one, so I've got the measuring spoon just to make sure. So I'm going to put just there, and this is a teaspoon. I would suggest using a teaspoon. You could even use bigger glasses, but a teaspoon of salt is a lot. And a teaspoon. So there. So each one now has a teaspoon, and I'm going to pour my water in. So I'm going to start with my cold, just because it's on my right and I'm right-handed. And I'm going to pour the cold water in. And I'm trying not to pour the ice in. So I'm pouring my cold water in. Ooh, it really, really disturbed it. Now I'm putting my lukewarm water in, which is my room temp water. Just see what that's going to do. Fill it up to about the same level. I'm trying to put about the same amount of water in. And now my boiling water. Remember, be very careful with this if you have your parent help you out. And I'm going to fill it to about, you can even see the steam. There we go. It looks like our cold water got short a little, so I'm going to add just a little bit more cold in there. There we are. And a little bit more of this. And now we can look inside and we can see, put the hot back here. We can see that, whoa, this one has a little bit of salt left around the back edge. Looks like this one got cloudy. Like the salt just sort of decided to float around inside of it instead of totally dissolve, but it also has salt at the bottom. And this one is very clear, but you can see on the outside condensation on it. But inside there is a ring of salt around the bottom. It looks like this one dissolved almost all of it except for a very small amount back here. Just a very small amount. And now, they all kind of look about the same, honestly. Now I'm gonna take my spoon and I'm gonna stir them a few times and see if I agitate, if it'll help them to dissolve a little faster. Just did 4 stirs on that. 1, 2, 3, 4 on that. and 4 on this. Oh yeah. Huh. And now we can watch and see if over time they dissolve faster. So I might come back and say 5 minutes and see if any have dissolved more than the other. I may stir them again just to see what happened, but it looks like they're all dissolving at similar rates. The hot water seems to have less salt in it. It definitely looks thinner, like the amount of salt at the bottom. And if I look at the side, it looks like a lot less salt than what are in the other two. Interesting. Well, I'm going to try this experiment 3 more times and see if the results are always the same. And I think I'm actually going to put a timer on them, so I'm going to time it. So I'm going to check it at 1 minute, then I'm going to check it at 5 minutes. And every time I check it, I'm going to stir it 4 times and see if that affects how much is in here. Wow, yes, the hot water is definitely dissolving. It's almost completely dissolved, while the other two, it's just sitting at the bottom. Now I'm interested to see if sugar is affected in the exact same way, because sugar is also a crystal. So salt and sugar are both crystals, and I wonder if they dissolve in the exact same way. Which makes me wonder, is there a difference? Like, do all crystals dissolve in the same way? Now I have a new hypothesis I need to form. All right. Well, me and Mr. Bones are going to say bye to you. So, bye.